In this video, we'll do problem number 5, where we identify the histogram for the frequency distribution given here. And it's very easy to just look at how there's very few values in the first class, then more in the second class, and it goes down a bit in the third class, up again in the fourth class, and then down again. So it's going from, it'll go from low to high, then back down, then back up, then back down. And we can tell the frequencies by the lines in the tables here. So I'm going to look first for the first class, the first bar in the histogram to have a height of 2. So it's not going to be option A. It's not going to be option B. It could be C, and it could be D. But notice that D goes up, 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 and then down, whereas C goes from down to up, down, up, down. And if I looked closer at all of the heights of these, they match the numbers in my table. Problem number 6 gives us the histogram and asks us to identify class width and sample size. This is easy to do also because the class width is the distance between the edges of each histogram bar, and they should be equally spaced. So notice that if I subtract 6 minus 1, I get 5. 11 minus 6, I get 5. 16 minus 11, I get 5. So the class width should be 5. The sample size would be the total of all the frequencies. So I see I'm just going to use my Excel to do a little mathematics here, even though you could probably do this one in your head. But I'm just going to enter the first class has 4. Then the next class looks like about 7. Then 3. And then 5. This one looks like 10. And 6. Now I can find the total by just taking the sum of all those values to get 35. Okay, so not bad, right? This one's number 8. It says, determine the distribution of the data pictured below. Right now, it looks like all the bars are pretty close to the same height, so that is uniform. And then we can do a new version. That also looks uniform. This one has a bell shape to it, so that would be bell-shaped or normal. This one looks uniform again. Let's do a new one. Ooh, this one has a longer tail on the left side, so that would be skewed left. And then you might guess that there could also be one that's skewed to the right. If you do enough, here's one that's skewed to the right. All right, skewed to the right. Notice it just kind of, the tail points to the right. For this one, we can identify the 5-number summary, which is the minimum 5, the first quartile 7, the median or the second quartile or the 50th percentile, the median is 8, the third quartile or the 75th percentile is 14, and the maximum is 20. And we have one more here where we're asked to identify the distribution from a given box plot. Notice that this has a long tail on the left, so that would be skewed left. This one looks like it could be normal because everything is kind of in the middle. You see the median is, in the center of the box, and this looks pretty centered, but everything looks so equally spaced that I'm thinking it's uniform. The bell curve um, would have smaller inner box compared to the tails. This is a left skewed again. Okay, so left skewed inversion. That one looks normal. You see how this one's smaller box in between and then longer tails. So if the tails look longer than the inner quartile range, that's normal or bell shaped, and normal mean the same thing. Let's just check it. New version. That one also looks normal, bell shaped. See, yep, that one's right skewed. This one also bell shaped. Okay, this one looks maybe uniform because now the distance between the minimum and the first quartile is exactly 1. The distance from the first quartile to the median is almost 1. And from the median to the next quartile, 1, distance of 1 every time. So that's uniform.